The periodic table of the elements is a chart that shows all of the elements that exist that we know of. Everything that we know that is called matter is made up of one or more of these elements. So these elements combine to make every type of matter that we have here that we know of on the planet. And this one's color-coded beautifully, so each of the little boxes up here that represents a different category or classification on the periodic table. So if you look, this light orange color represents the alkali metals. A little bit lighter orange is the alkaline metals, and each of the colors represent different classifications, and it usually means that the elements that are in that category behave very similarly when they're in chemical reactions. So for example, lithium is an alkali metal and sodium is an alkali metal, and they tend to behave very similarly. If you take a look over here, we've got the noble gases. The noble gases are the famous guys on the periodic table. They have full valence shells, which means they're very unreactive. They tend not to react with other substances because they've got full valence shells and they're happy guys. So we call those the noble gases. You have to be able to read the periodic table, and so I've put a little box here that shows you what you would typically see in a periodic table box. The top number represents the atomic number. So carbon, as the atomic number for carbon is 6, which also refers to the number of protons that you would find in the nucleus. The symbol for carbon is a uppercase C, it's a large C. Here's the name carbon, and it's a proper name, so we capitalize them. And then the mass of an atom of carbon is 12.01. We often just say the mass of carbon is 12. And the mass is measured in atomic mass units. And so here we have the periodic table again. And we want to make sure that we can understand that we classify it into pretty large groups. So if you take a look at the periodic table in terms of these columns, these vertical columns are referred to as groups. And elements that are in a group will typically behave similarly. So they will react in a chemical reaction very similarly. Same as this group, this is group 2. So this is group 1, group 2. If you notice, helium or hydrogen is not included in this group because, well, it is included in this group, but it's not included in the classification here. It's got a different color. But hydrogen will behave similarly to all of these elements. All of these elements will behave similarly in a chemical reaction. The next thing that we have to look at are the horizontal rows. Those horizontal rows are called periods. And if you take a look along a period, what we end up seeing is increasing atomic number. So this one has an atomic number of 1, which means it has 1 proton in the nucleus. Here's an atomic number of 2, so there's 2 protons in this nucleus. 3, 4, 5, 6, 7. So as you go along a period, you will see increasing atomic number. You'll also see an increasing atomic mass because obviously there are more subatomic particles. So this one's got an atomic mass of 18.9. This one has an atomic mass of 20.1, and so on. So as we go along this way, we get increasing atomic number and increasing atomic mass. The next thing that you have to be able to understand is there are large groups. So this big large group here, which encompasses most of the elements. All of those are called the metals, and it goes all the way along to all of these guys. These guys are all metals, and these guys down here, they're called transition metals. We're not going to talk a lot about them, but on the left side of the periodic table, you'll find the metals. And then if you take a look along the right side, you'll find the non-metals. So all of these guys in the purples and the blues, these guys are all non-metals. And then you'll have these green guys in the center. They are actually in between metals and non-metals, and we're going to call those guys metalloids. So they're not quite metals, they're not quite non-metals, so they have sort of metalloid qualities. So they're sort of metals, but sort of non-metals. So we're going to call them metalloids. Almost like a humanoid. It's not a human and it's not a robot, so we'll call it a humanoid. And then the last thing that I want to talk about is valence numbers or valence electrons. And one of the things that I'd like to show you is an easy way to determine the valence electrons in each of the groups of the periodic table. So if you look at this group, this vertical column, this is called group 1, and everybody in group 1 has one valence electron. So I'm just going to put 1 and then a little 1e negative, so 1 electron in its outer shell. Group 2, they have 2 electrons in their outer shell. And so all of these guys will have 2 electrons in their outer shell. And then I want you to skip all these guys here, and I want you to go here. And this one, I'm just going to ask you to circle the 3 there. This guy has 3 electrons in its outer shell. And these guys have 4 electrons in their outer shell. These guys have 5. These guys have 6, 7, and then the noble gases, the non-reactive guys, they have 8 electrons in their outer shell, and that means that they're happy, which is why they are non-reactive. So the noble gases are non-reactive. So if you have this guy who has 7 electrons in its outer shell, this guy is probably going to, anybody in this column is probably going to react quite well with a guy over here who has 1 electron, because 1 plus 7 equals 8, so you'll make happy compounds. And one of the most common ones we see is sodium chloride, which is salt. And so if you take a look, they usually come together, sodium and chloride, because this guy has 7 electrons, this guy has 1, so this guy will say, hey, I'll give you my 1 electron so I can be happy. And chlorine says, sure, I'll take your electron because I want 8 in my outer shell and I'll be happy. So that's just a quick, easy way to take a look and see how many electrons are in the valence or outer shell of the atom.